Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Nebraska's Carolina Bays. This video discusses the Nebraska Rainwater Basins, whose elliptical geometry was discovered relatively recently. Many hypotheses about the origin of the Carolina Bays have failed to consider that the Nebraska Rainwater Basins have many features in common with the Carolina Bays, and that both may have been created by the same physical mechanisms. South-central Nebraska is predominantly a large plain of fluvial sands and gravels deposited on the southern side of the Platte River. All the terrain is covered by several meters of loess, which is a loosely compacted deposit of wind-blown dust. The area has many shallow lakes, marshes, and other wetlands known as the Rainwater Basin wetlands. In the spring and fall months, millions of migratory birds pass through these wetlands to feed and rest. The birds eat the seeds of wild plants and grains from surrounding farms on their way to or from their nesting grounds. The wetlands are managed by federal and state agencies with funds obtained from hunting permits. Agricultural development at the beginning of the 20th century started converting the large, flat wetlands for crop production by draining the land and diverting runoff towards streams. The satellite image on the left shows the half-mile circular patterns created by center pivot irrigation systems. The LiDAR image of the same area on the right reveals elliptical depressions known as Nebraska Rainwater Basins that occur south of the Platte River on the loess-covered landscape. In 2001, Zanner and Kuzila presented a paper announcing that Nebraska had geological structures similar to the Carolina Bays. The Nebraska Rainwater Basins were originally discovered using digital orthophoto quadrangles, a technology that preceded LiDAR. The Nebraska Rainwater Basins are oriented from the northeast to the southwest, almost perpendicular to the orientation of the Carolina Bays. The paper announcing that the Nebraska Rainwater Basins were analogous to the Carolina Bays was preceded by a geological exploration of the Nebraska Basins in 1994 by Kuzila. This earlier work drilled 17 test holes in 2 sample areas to determine loess thickness and stratigraphy. This image is for sample area 1. Michael Davies from Syntos.org obtained a LiDAR image for sample area 1 with the location of 10 test holes. The LiDAR image can be superimposed by an ellipse to demonstrate that even though the eastern portion of the basin is eroded, the rest of the basin preserves its elliptical geometry. This image overlays Kuzila's line drawing on the LiDAR image showing the locations of 10 test holes. The features from 1994 correlate well with the 2018 LiDAR image. Kuzila found that the modern basin landscape resulted from the deposition of 2.5 to 8 meters of loess on an older basin landscape. The modern landscape generally mirrors the paleo landscape, except that the modern basin ridges seem to have less relief than the paleo ridges. Zanner and Kuzila proposed that the basins originally formed as blowouts or low spots in abandoned Platte River fluvial sands and gravels, and that starting approximately 27,000 radiocarbon years and later, loess covered a pre-existing topography formed on these sands. The loess is covered by a layer of modern soil. The Nebraska Rainwater Basins occur in terrain that is 550 to 650 meters above sea level on sandy soil south of the Platte River. Nebraska has not been close to any sea since the Laramide orogeny started building the Rocky Mountains and drained the western interior seaway more than 60 million years ago. In contrast to the coarse, loess-covered terrain in Nebraska, the Carolina Bays occur in fairly smooth sandy terrain at elevations usually not exceeding 50 meters above sea level and within 100 kilometers from the Atlantic coastline. The images show that the Nebraska basins have been subjected to greater erosion than the bays in North Carolina. Since ellipses are conic sections, the precise elliptical geometry of these geological features is a good clue that the Carolina Bays and the Nebraska Rainwater Basins originated as inclined conical cavities. The width-to-length ratios of these particular ellipses correspond to cones inclined at 43 and 39 degrees. The glacier ice impact hypothesis proposes that an impact on the Laurentide ice sheet ejected ice boulders, and that the secondary impacts of these ice boulders created the inclined conical cavities that produce the Nebraska and East Coast features. In order to justify the dates obtained from the cores, the impacts in Nebraska would have had to create inclined conical cavities on the lowest covered landscape, and viscous relaxation would have had to restore the original stratigraphy. Although experiments have shown that viscous relaxation can restore the stratigraphy of a cavity created by a plastic deformation, additional impact experiments are needed to determine the mechanism by which loess with its modern soil cover is restored on the top layer. There is still plenty of work to be done to understand exactly what happened in North America toward the end of the Ice Age. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.